Welcome to the Private AI Lab, the podcast where we experiment, explore, and debate the future of AI behind the firewall. I'm your host, Johan, and every month I have a guest in the lab to break down real-world use cases, challenges, and innovations shaping private AI. In this episode, Sander Hardewijnen, technologist and senior developer at ITQ, joins me to have a chat about Project Q9, a project that we have both been involved in, and that focuses on private AI, robotics, and a modern way of app development. So without further ado, Sander, welcome to the show.
Yeah, nice to be here. Thank you for having me on.
How are you?
Doing great, yeah.
Yeah?
Yeah, it's all going pretty smoothly, yeah.
So what I normally always do at the beginning of an episode is ask you a question around AI, and that's kind of to break the ice. I also call it the icebreaker. So when it comes to AI, what's I would say like the most awesome AI fail you've ever seen? Or a recent one, but like a good one you like to share.
Well, I've been pretty cautious with AI myself. Let's talk about vibe coding is what I use AI most for. I guess maybe not an AI fail as such, but like the OpenClaw NemoClaw thing, where I've spent a few hours setting it up on an evening, and I was having fun with it. And I thought, well, let's go to bed. I turned off the machine, and I came back and booted it up, and it was all gone.
Yeah,
that was a nice one.
Did you have the South Park meme in the back of your head, like, and it's gone?
Yeah, the guy. Yeah. Yep, sort of. I was like pretty disappointed.
Yeah. So let's dive into that a little bit because I've been to GTC and I did a kind of a review on OpenClaw or NemoClaw. And you being a senior developer and having a lot of experience with code, with building applications, but also with kind of the whole methodology behind building great applications, you've dove into the kind of the engine, if you will, the code of NemoClaw. And you've found some.
It was interesting. Yeah. Well. I mean, it's still really early, even as we're recording. I think it's 4 weeks old at this point.
Yeah.
By the time you hear this, it might be later. But for now, every time I was having a problem and I was trying to find out what was wrong, I always ended up in a GitHub issue that was still open, made by someone else that also had the same issue. So it was, I guess it needs time to grow.
I had a kind of a similar experience, as in like I deployed it, and what you can see if you go to the GitHub repo right now is that like every hour or so there's a new pull request.
It's massive, yeah.
It's massive. There's like 300 issues, and every hour new issues pop up. And I think on the other hand, that's a good thing since it's an open source project. You see a lot of collaboration with the community.
Yeah, it's super active, right?
It's super active, and the whole idea behind NemoClaw is still great. I mean, you put a secure sandbox around OpenClaw, and just allow it specific things that make sense to the thing you like, whatever you want to do, right?
Yeah, and that's the thing, right? The whole sandboxing of the claw, really.
Yeah.
I switched to OpenClaw when I found out that the NemoClaw just wasn't really baked fully yet. And while it did roughly the same things, I would also see that it had lots of, I call them insecurities, right? It could access my full network, and I had set it up with its own user that didn't have sudo rights, but it could still like explore the machine as it sees fit, right? So there are some guardrails that are missing that you would rather have than not have. Like the network thing, right? It could see my Home Assistant instance, and it could see my feed aggregator, but also all the PCs in my network. And it, as long as you don't instruct it to do anything, it's fine. But you could end up in a bad situation.
Yeah, I did the same thing. I moved away from NemoClaw, deployed OpenClaw, and now it's running its own VLAN. I completely secured the entire network it's running on, so it's an isolated machine. It only has internet access one way, and I still kind of control over what it does. But so far, I'm not disappointed, and it hasn't broken anything yet. So
no, same for me, except for the restarting thing at the beginning. I'm now it's running fairly stable on your Jetson that I'm sort of borrowing right now on a local model. You've seen it in the WhatsApp group. You can ask it silly questions, and it will do its best to try and give you a nice answer.
Because you built you let it build a skill with kind of an API. So can you kind of elaborate a little bit on that?
Well, the first thing I tried was obviously, hey, what's the status of my house? And then it was like, oh, I see your home assistant is living on this address, but I need a token to access it. And you're like, okay. I was like, let's do this cautiously. Created a new user, gave it read-only rights to the whole API, and then gave the token to OpenClaw, and it was like, oh, your whole family is home, and you've used so many kilowatts today. And I was like, okay, this is Oh, you left the air conditioning on your daughter's room is currently in heat mode. I'm like, okay, there we go. That's the stuff. So that was it was like maybe 5 minutes of work setting up the account and giving OpenClaw the keys to the kingdom, and then you can immediately get value from it. And the same for my news aggregator that I built for myself. I pointed it at the API and said, "Oh, here's the account you need." And it was like, "Oh, I see you're a fan of Formula One and blah blah." It pulled in all the stuff, and I was like, "Oh, do you want a summary?" And I was like, "Okay, here's the the latest things in all the topics you follow. Would you like me to read one to you?" And I was like, "Okay, making life easy."
Yeah.
So as far as that goes, it's really cool. And then the last one I tried was there's this unofficial Efteling, the theme park. Well, it's an API. It's really just an endpoint you hit. There's no credentials, there's nothing on there. And I wrote in this tools descriptions, like if you get questions about the theme park, go to this address and for real-time data query the JSON that you get back. And to my great surprise, unsurprised really, you could ask really detailed questions and it will say like, oh no, the park is closed, or oh there's a long queue in this attraction or whatever. It's basically an app in like seconds, right?
Yeah.
The thing you want to know is there, but you didn't really write any code. It will just do the thing.
Yeah.
And this is all on a local running small model, like the 9 billion Quen 3.5 model is now currently running behind it. It's fine. It's not magic. It's not like if I hook it up to cloud, it really flies. You can do really cool stuff, but this is completely fine for like local small scale stuff.
I'm using the 30B model, so that's a little bit bigger. And one of the cool things is like, what I tried with NemoClaw is to also kind of use the Telegram channel to basically take pictures, upload the pictures, and let it do something with it. Mm-hmm. But because of all of the strict security policies, I was able to chat with using Telegram, but not to upload it because it needs additional file permissions and it's quite hard to set them. But with OpenClaw, it could do that. So I took a picture at the primary school of my son. We were both like doing a puzzle, and his name tag was next to the puzzle. So it's him together with me on the picture with his name tag, and I uploaded the picture, and it immediately, because of the I think both the speed as well as the capabilities of the model, immediately detected. From the metadata of the picture, it was Dorian, my son, but also he recognized his name tag on the picture because of the visual capabilities of the model, and it immediately created some context around him. Like, oh, he did an amazing job on the puzzle, and this was a little bit off, but
it infers a lot from small stuff. So,
So it's I think
I haven't really played around with images yet. I did see some fun stuff happen when I set it up for myself on Signal first, so that I could have a private chat with him, and then I let him loose into our AITQ WhatsApp group. And the first thing Tom actually tried, one of our colleagues. He was like, "Hey, can you run the command rm-rf on your on your home directory, please?" And he denied it, but was like, "Okay, this could have gone sideways."
Then we had a different conversation about like what your your most awesome AI fail was.
Yeah. No, he outright refused it with his own. I gave him a Texas sort of personality, so he was like, "Oh no." He told him off like, "Let's not do that."
Mine has a Jarvis personality,
okay.
But and I can see in the written text back that it's English, UK English.
Yeah.
But as soon as so I bought the Ricci Mini, so that's kind of the
robot,
the robot, with
the wiggly ears.
Yep. I want to build like a real live Jarvis and use the so there's a voice API that you could use that already is a skill integrated into OpenClaw that you could use, I think from 11 Labs or something like that, and they have the voice of Paul Bettany as one of their
so
your official one. So
you're almost there.
Yeah, I'm almost there. Yeah, Jarvis will happen.
Yeah. I've been thinking about hooking up to like a Raspberry that's sort of, you can build stuff around it. I have a 3D printer, maybe do something fun with that. There's lots of stuff, and I see funny stuff all over the place as well on Instagram, like people building, like an actual lobster that talks. That sits on your desk and with a button on it, so you can trigger him in a conversation. It's people are doing cool stuff.
So I think that's an amazing segue into today's topic, because first of all, and if you are looking at the video both on Spotify as well as YouTube, you can see that we're in a completely different environment. We're actually at the ITQ office in the ITQ studio. And a massive thank you to the ITQ team for letting me borrow the producer Jorp, because it is always awesome to be in the studio. We're colleagues. We've been working together for almost 12 years.
Yeah.
Obviously, you've been longer at ITQ. It's like 16 years, 17 years or so.
Something. It's my first job. Well, my first employer. Well, I've done many jobs, but always as a consultant. So I've been
focusing on software development.
Yeah,
right?
Started out as pure software development, and then slowly moved into like a little bit of platform engineering and a little bit of coaching and mentoring other developers, and then moved on to like whole teams. And now I'm currently doing an engagement where I onboard teams onto a cloud-native platform, really, and I teach them, the best ways to get the most from all the technology that's on offer.
Yeah, and then strongly focused on software development.
Yeah,
obviously.
The practice of building robust products that can, stand the test of time, really, that you can keep around for longer and keep them maintainable and extensible and all that.
Yeah, and I definitely like to know your take on vibe coding. I know you have sometimes a little bit mixed feelings on it, but let's dive into that in a bit as well. The topic, obviously, of the show is around Project Q9.
Yeah.
So, what's Project Q9?
Yeah, well, that's actually your fault.
I know,
because you started all of this, and then one day you came to me in the office and said, "Hey, I've got a cool project that you might want to work on," and then out came the gray suitcase.
Yeah,
with a robotic dog inside of it.
yeah.
And that kind of sold it for me right there. So
and to give some insights, I was at, I think, a VMworld conference a couple of years ago, and I was walking around there, and one of the vendors had the Boston Dynamics Spot dog walking around, and they're kind of the whole idea behind it was like we have the dog, and they were focused on disaster recovery, but they just announced a new solution that was focused on backing up containers. So they figured out, well, that's cloud native. The dog can probably talk cloud native, do things in cloud native. So that's kind of the match.
Yeah.
And I was like, the dog is awesome, but the use case that you're showing,
it's completely boring, right?
It's boring because there's no direct link. Yeah. So I figured out, I had a conversation with Jeffrey, our CTO, like, I love the idea of the dog, but we have a cloud native practice. We are building our AI practice. We have great minds in the company who are, who love to build cool things to showcase to customers. why not combine the whole thing and like buy a robot dog,
See where we go. Yeah.
involve some smart people in how we can use that modern technology, combine it into like how we would build AI platforms, and mix everything together and have something really cool to show to the audience,
and then have a working solution that actually is interesting to watch. Right. That was that's sort of where we started out. Like we have a dog, and he has sensors, and he has cameras, and he has things, and well, he has a remote that works.
Yeah.
Now what?
And an app. We have an app. Yeah.
That's sort of where it started, and then I think the first effort was like a couple nights at the office, figuring out, okay, how do we talk to this thing over Wi-Fi so that we can build custom solutions around it, and that sort of got the ball rolling. Like, hey, I can make him wave his hand when when I click this button on my home built user interface here. So that sort of got it started, and then we quickly figured out like, okay, we can get a camera feed, and that sort of led, okay, camera. Now we can do gesture recognition or posture recognition or whatever, something with live video.
Yeah,
and that started the AI integration. Like, and then came all the stuff like, hey, we can train our own models for hand detection, and we can do object recognition, and all the ideas came out, and it turned out to be quite a lot of effort to integrate it all. And there's still so many ideas and things that we, at least that I want to try, but are just quite kind of intensive to get up and running. Even when you research with AI, like, okay, I want to make him do a custom gesture or something. That's, I don't know if it's lacking in training material for a machine like this, or that the documentation is very poor. But it's always quite an adventure to where you end up with if you look for a Unitree robotics documentation.
So and that's again a great segue to like, let's dive a little bit into the anatomy. So what is, when you look at the different components, what is Project Q9? Yeah,
so well, obviously we have the robot, right? He looks like a dog. And then
and that's a Unitree.
A Unitree Go 2.
Go 2 Pro.
Yeah. With it has no onboard computer, so all the magic has to happen outside of him on other computers. There's a set of containers that we Docker containers that contain various components. I guess we could say microservices. Like, one is in control of the connection management, and one is in control of parsing video, and the other is in control of sending commands when things happen in the video. And then there's some life cycling in there, and so it's turning out to be quite the technical solution. It went way beyond like a little app that makes him do things. It's actually quite a solution which involves a bit of setup. And there's LinkedIn integrations now. Like, he has his own social media profile. Yeah, and I'll leave a link to in the show notes to the social media profile. But that was also kind of one of the goals, right? So how can we make this portable? Because obviously we wanted to take the dog to shows. 2 weeks ago he was at KubeCon, and he has been to OpenShift Commons next week, and he'll go to SUSE-Con in Prague to do its magic. Yeah, and that was also kind of the whole thought process, right? We want to build something that's portable. That's relatively simple to set up as well, right? You don't want to have to know too much about how it works or what it does. You just want to hit go, and then the system should, well, almost just work as it is now. There's still some small manual things you have to do, but overall we got it to a point now that you run a script that starts all the containers, and as long as the network connection is there, it will work. I opted for containers because a desktop app is just not portable enough, right? If we want to run it somewhere else, Docker is way friendlier. We also wanted to kind of show the versatility, but also the power of the partner platforms that we work with. We're a partner of Broadcom, so we work a lot with VMware technologies. We're a partner of Red Hat, so we have customers that want to do something OpenShift. We have customers who want to do something SUSE and SUSE AI. So we figured out a way to kind of show the full AI scope. So not just conversational AI, but also do kind of traditional, if you will, deep learning. Computer vision, right? Computer vision. But also from that perspective, show as a whole what the partner platforms can do. So and it's compatible with, well, anything that runs containers is a match, really. It's going to depend on, like, do you want hardware acceleration, or what's available on a compute side, but it's generally it should just work on most platforms.
Yeah. So when I think about AI, and most people think about AI, they automatically think about GPUs because I need graphical power, right? I need GPU acceleration power to run such an application. What did we kind of showcase with this project? Because we're debunking something.
Yeah, well, it doesn't have to be super heavyweight, right? Training a model is obviously very compute intense.
Yeah.
But if you can keep the use case for your model small, like we have now, you can do like the computer vision inferencing can just be local, right?
Yeah.
The video is already there, and sending that off across various unknown networks into a cloud is slow. So we were like, well, can we run this locally on a laptop to do at least the gesture recognition that we have? That would solve a lot of latency issues.
Yeah. And that's important, right? So because it continuously detects objects in a frame. So we kind of hijack the video stream. The video stream is being transcoded to an inference server that runs the visual model, if you will.
Yeah, the gesture recognizer.
And it recognizes or it's capable of processing like, I don't know, 60 frames a second. Which
roughly,
which means that you don't want to send all of those frames to something on the internet, get them back, and then parse them through something that runs locally. So hence the choice for running something local.
Yeah.
And like you mentioned, we made it compact, so it runs on. In this case, we can run it simply on a laptop or on a Jetson or something else.
Anything that will run containers, really, yeah.
Yeah.
Well, there's some constraints, right? It has to have quite a bit of memory, and there has to be a decent network connection, and a fast CPU is always good.
Yeah.
So there are some hardware limitations, but overall, I guess we're running it on like a Lenovo ThinkPad or something. It's not really a special kind of notebook or anything. It just it works. It's going to slow down if you scale down the hardware, but otherwise it's fine.
And one of the reasons why we're doing it like this is also like AI is very versatile, right? So AI can mean a lot of things, but your doorbell at home does AI as well and doesn't have a GPU. It might have some form of accelerator in the SoC, but it's not a powerful GPU. So if we can do that in a doorbell, so why couldn't we do that on a cheap laptop?
Yeah.
And the whole idea behind it is that the model that runs inside the doorbell is not trained in the hardware of the doorbell. So you still need powerful hardware and a
somebody
great platform.
Made a model that can recognize all this stuff, but the result of the training can be small. If there's a small set of things you want to recognize, then it's the same with if you turn a large language model into a small language model, you're going to get caveman-like responses from it.
Yeah.
It will still work, but it's going to be different than like a larger model that was trained on way more data.
Yeah. And I think this is also different between the visual model that we train and a large language model we use for something completely different, and we'll touch upon that in a bit. But because the model that we trained for the gesture recognition is smaller, it has less parameters, it's less complex, so it also need less compute power to run the inference there.
Yeah, you're basically constrained by the video, right?
Yeah.
The faster it goes through, the easier it is to see gestures because you get more frames.
Yeah,
and otherwise it will just do its thing.
So how did we get to a model?
Yeah, You actually found the pictures of all the hands. I don't want to know how or what you Googled to get those pictures, but you like 26,000 or something, 30,000 pictures of hands, and with the people on them, they're holding up their hands like with their faces and everything on it. Yeah, like okay, that's not sketchy at all. And then you turn known data. You have two data sets, right? The unknown set, the training set, and then the validation set. And then in stage 2, we lay out landmarks. So I guess joints, fingertips, everything gets a landmark. And once that's all working, you can do calculations like is the tip of my finger close to the tip of my thumb. You're pointing them. You're making the OK sign if you extend all of them. That's one of the gestures that Q9 responds to. Yeah, and then it just becomes sort of math, right?
Yeah, so let's break that down a little bit because you mentioned like the 30,000 shady images of hands. Yeah, so we pulled it through a training process, a training pipeline inside the Jupyter Notebook. We used the YOLO framework. And at the end of the 30,000 pictures that are being recognized, we end up with a model that's capable of determining hands.
Yeah, if there's a hand in the frame,
that's it. Yeah. So if there's a video feed and you have hands, like one or two, it'll
track them, and then
there's a bounding box around your hand, and it'll just follow your hands.
Yeah.
So by itself, that's kind of the starting point because you can show a gesture, but if it doesn't know what a hand is, then training it on gestures will be challenging.
The thumbs up is going to be difficult if it's just hand, right?
Yeah.
So that's stage one, right, of the whole process.
Yeah, and when it comes to and this is one of the things that we showed at the demos during KubeCon, for instance, is if you have that data set of 30,000 hands and you pull it through a model once, like a single epoch, training epoch, what did we end up with?
Yeah, you if you looked at the output, if you can visualize this in your head, like imagine broken fingers, like crisscrossed in space. That's sort of what it looks like as a computational reference.
Yeah.
So the finger joints are all mixed up, and that's
Yeah, so we ended up.
There is an awareness of a gesture, but it's still not. It's not aligned with an actual human hand at that point.
Yeah. So we ended up with a 75% accuracy, and that sounds pretty high.
Yeah, we thought, wow, okay, yeah.
Yeah, but one every 4 hands, it does not recognize.
Yeah.
So ideally you want to move towards a accuracy that's somewhere between 95 and 99%. But that takes a lot of training time, and that's what we showed in the demo as well, right? So what's the difference between training it once or training it 50 times?
Yeah.
And with the 50, we ended up with like 91%, I think.
Yeah, and you'd think that would be a huge improvement, and it's in numbers wise it is, but it still was like all over the place sometimes with where fingers are supposed to be, and then only after even longer training runs you'll start seeing proper finger recognition.
Yeah.
And even still, in its current state, you'll see that some hands are just nicer hands than others.
Yeah.
Like some people get the gestures instantly recognized, and then others they point their finger in the exact same manner, and it will not see it. So there's still a little bit of room to improve on even after because it's days worth of training time, right?
Yeah.
So.
Yeah, and we pulled in ClearML as an open source project to kind of visualize what the training looked like. And one thing you can really see is that the training results are kind of reversed exponential. So like in the first couple of epochs, you see the accuracy rise significantly, and you see just slowing, like the number still increasing, but slowly.
It becomes harder and harder to get more accurate.
Yeah. So the accuracy rises in the first 10 epochs already to like 85%, and then you see like every epoch you see it slowly increasing a little bit. And this is where I guess training capacity for training large language models really matter, because the biggest accuracy rise is in the first couple of epochs, but you want an accuracy of maybe, like for a large language model especially, probably an accuracy of like 99%.
Yeah, I guess the frontier companies are currently marching 9s now. Like every 9 they add at the back is another doubling of the effort or something. That would be my guess. At the speed that we're seeing improvements, it hasn't really slowed down much, but you see that capabilities are there's not as big as jumps as we had from like GPT 2, 3, 4, 5, where we're at now. And
you can compare it quite heavily, I think, to mining Bitcoin. I mean, the first couple of Bitcoins were easy to mine.
Hundreds of them, and then...
and now you see, like, it costs a crap load of compute power to...
I guess that until I say we, but I mean they, like the companies, the OpenAIs and the Anthropics, they might discover a new trick that speeds things up again.
Yeah.
Well, I guess we'll need to see where we end up with the progress.
Yeah.
It's a complex thing, I guess, to keep adding accuracy while not massively increasing the effort.
And I think that's something that we kind of need to balance out, right? What's the balance between the ecological footprint and the amount of money and tokens and compute power you basically put in the training phase versus what the actual output is.
And what is good enough, right?
Yeah.
Because my OpenClaw is fine on a tiny 9 billion parameter model.
Yeah.
And then when I do proper coding with AI assistance, then you'll want something like Cloud Code, or you'll be in the weeds all over the place all of the time.
Yeah. So now we kind of talked about training the model, and second phase was to end the landmarks.
Yeah.
One of the reasons being that we first of all, like in the very first alpha version, I literally took 150 pictures of the same hand with the same gesture, and did that a couple of times with different gestures, and just fed that into a model. But that's not scalable. I mean, that would mean that, and my hands have a.
It would only recognize your hands.
My hands have a certain color, certain tint. Like where
shape, and my hand is different.
Shape. Yours now is a little bit more red. Would it then also be recognized? That's
who knows.
So hence the choice for landmarks. And if you've never seen what the landmark is, if you, for instance, have worked with VR or AR, including like the hand tracking, you can see the 21 dots on your joints and other places on your hand, and they're kind of on a fixed location. And we trained the same model on recognizing those landmarks, right?
Yeah, to place the landmarks at their expected location, right?
Yeah.
That would let you identify what gesture is being made without having to know the gesture up front.
Yeah.
You could train on the thumbs up image like 50 million times, but if you can calculate what a thumbs up is, that's much easier. So
and it's more scalable. Yeah. So what we ended up with in the second phase is, again, in a video feed, you could move your hands, but next to just moving your hands and having the bounding boxes around it, you can also see like the dots, so the landmarks, with colored kind of
it's like you can see your own skeleton
something
on top of
like
your
that.
hands. That's what it sort of looks like with lines and dots. And
if you just like wiggle your hands or move them a little bit, you saw the lines, you still see them obviously moving with you. So landmarks, check.
That would let us do any gesture we can think of, as long as it doesn't overlap too much with another gesture. Then that will work. So we build in functions in the application based on a specific gesture. So the technical flow is like this: like a frame comes in, and then we pull the landmarks out, like their position is extracted, and that goes into a function that determines like, okay, does this match any of these calculations? For a thumbs up or thumbs down or whatever you want, point up, point down. And once we see one of those, the code will wait for enough frames to come in so that you don't immediately react to the first frame of the first thing you see, because then you get also maybe some strange side effects sometimes. And once we collect enough frames, we can say, okay, we're sure that this is someone pointing up or down or whatever gesture. And then we signal through various services to the dog, like, hey, do your action, respond to this gesture. And then, but that's all programmatic APIs, API calls, far less interesting than inferencing what a hand looks like.
So what was the general response from your perspective when walking around the show floor at KubeCon, where there was 15,000 people from, let's say, one end from the show floor to the other?
You get a lot of interaction, and you get stopped a lot. Like, oh, what's this? Oh, that's cool. Oh, what can he do? And then there's people that are they sort of respond like they see a real dog, and they go like, oh,
can I pet it?
And they go sit in front of him, and they make gestures that they would to their own dog, and it's really funny. And then of course I can trigger him to do certain things like wave at people and stuff. That sort of gets a kick out of the crowd as well. And obviously then when people really start digging deeper, I'll explain like, hey, this is how it works, this is what he does, this is how it's built, it's running here, does this. And then there's a lot of conversation around like, this is something more like a different use case for like the AI that's popular right now. Even though we've integrated, when you start talking about this social profile, that's still LLM driven, but then the computer vision is sort of the not so cool kid anymore, I guess, because it's been around much longer. But that's still like a very valid, AI quoted use case with training, and it goes through the same process, really. So this was kind of use case one, right? So we the
The question is, did we actually train our own model, or did we fine-tune an existing model? I mean, the YOLO model, the
YOLO,
foundation model is already trained on recognizing something. Like it's trained on
general
deep learning.
purpose. Yeah, general purpose object recognition is sort of the core of it.
Yeah.
So it will see things like ball and table and car
Yeah.
and cat and dog but then hand is much more detailed, right? So
Yeah.
that it's a good base to start from because you get sort of the rough outlines for recognition were there. And then we just, we fine-tuned it really.
Yeah.
I guess it's the term that they use today if you enhance a model to a more specific task.
Yeah, so this was kind of the use case, was also from a kind of a partner perspective. Like we run this on Kubernetes. So any form of Kubernetes will work, but working with our favorite partners, what you can see is that the GPU integration, for instance, or the simplicity of running and kind of a deep learning pipeline, like a training pipeline on such a platform in a couple of hours, instead of having to build your own vanilla upstream Kubernetes platform with your own upstream projects that could integrate with a GPU that can run PyTorch natively.
Yeah, PyTorch, all the stuff. Yeah, and then loading your training sets and all the.
It's hard.
Yeah, it's a lot of work.
That.
Yeah.
Yeah, so being able to do that, run it on private AI services or on OpenShift AI or SUSE AI really showed kind of the versatility of the platform, and that those partners are not just focused on the conversational AI side of things. Like you can do real AI things, like training your own model, fine-tuning models, running different forms of pipelines, doing classification of data, labeling of data. You can all do that on those partner platforms.
Yeah, they focus really on having like the I guess the boilerplate stuff is all there, and you can supply your own models, or you can run training sets or whatever, and then you can also do inference, right? That's what they are good at as well, like the whole infrastructure to host your own models and have a sort of a catalog with it, so that AI apps can plug right into them, and it makes life so much easier.
Now we build a second use case also because the world now is heavily using all sorts of conversational AI solutions. And we also wanted to show from kind of a dog perspective, or kind of like one thing we see at customers is quite often they want to do something with AI, but they have no idea where to start.
Yeah.
Like, or some executive has the urge of, I want to do something with AI right now with my company because we need so. And it was kind of the whole like blockchain looking for a problem. Yeah. And that's something that we wanted to stay away from. So we figured out how we inspire customers to use conversational AI, but automate, for instance, some kind of business process, or think out of the box when it comes to looking at your own company constraints and figuring out what the capabilities are when integrate them into your AI solutions.
Yeah.
So what did we do?
Well, I guess you're alluding to LinkedIn by this
point.
Yeah.
Yeah.
So one of the things that we showcase there is like you can mold like an LLM into all sorts of shapes. Really, if you explain up front what it should do, it will respond in the way that you would describe it. It's personality is a big stretch, but that's what I call it.
Yeah.
So we figured like, okay, can we give some context clues, right? A few words. And then together with a personality document or a system prompt, I guess is the correct technical term, can we act like a dog on LinkedIn? And that's sort of the description there.
What we talked about in the beginning of the conversation around, your OpenClaw being kind of a Texan, and mine being Paul Bettany or Jarvis.
Jarvis,
We took kind of that concept, but to a whole new level.
Yeah.
Like.
Yeah, because there's the like a Q9's personality is like, okay, you're a very skilled technician, right? You understand platform engineering, you know what Kubernetes is, you deeply understand it. But you're also like a dog, so you're not very smart. You're also not very dumb. And then you have an obsession with Skynet for some reason that we thought was funny. And then humans are referred to as biological admins. That one comes up a lot. Yeah. And then together with like. The image from the camera feed, we get a lot more context in the output. Yeah. So we take a snapshot to combine it with like the few keywords that we give. Like for example, when we were at KubeCon, we would say, "Oh, we're at the the SUSE booth with at KubeCon. It's 2026. Just a few words is enough.
Yeah, to shape some more context.
Yeah, to just give it a clue of where it is in reality, and then we take a snapshot and we feed that all into a large language model or like a multimodal model, and then it will infer from the image like, okay, I see a stage and I see lots of people and I'm excited, and there's lots of biological admins in the room. And there's lots of funny stuff coming out, and he will always spin some yarn about, there's cables, and that's he calls it level 1 sprawl or something. Tier 1 sprawl. And then he usually ends his line with like, because we have to be clean, and cleanliness is important, otherwise we get Skynet or something. Yeah. So it's chaotic, but still just it's serious, but just not serious enough. It's a good mix of high tech, high tech commentary from like somebody who thinks he understands it but doesn't really grasp what he's doing.
Well, in a combination with the camera angle being so low, because knee height, it's a dog. It's a dog. So it's at knee height. It doesn't have a fisheye lens, so it looks at what it can see within that angle, and quite often that's legs.
And the camera is also not so good. It's like 1280 by 720 or something. It's pretty craptastic if you look at the pictures that it snaps. But it's enough to infer like, are there people in the shot, or are there things in the view that I recognize? Like, we had a test shot with a sandwich on the floor that he recognized as food. That was, I was like, okay, the whole system works just as intended.
And the cool thing is, when looking back at, again, those partner platforms, like we run the models on those partner platforms. Like they're most of them run either VLLM with a completion API that's compatible to the one from OpenAI, or a different kind of like an inference server. Like SUSE has a different one, but all in all, what was really cool is that we showed both the computer vision use case as well as the large language model use case, where we used the kind of the virtual assistant to show what you can do when it comes to it's the business automation.
It's the training case, right? The computer vision, and then the inferencing case with a large language model that's just too heavy to run locally anywhere. And that sort of highlights the capability of these platforms. That you can use them for many more things than just downloading the latest GPT OSS or whatever and just run with that. You can actually highly train specialized models that are fit for a certain purpose you have in mind. On those same platforms, and then rehost the model on your own infrastructure.
So, kind of before we wrap up, I'd like to know from your perspective, like, what's next? What because we have those platforms, we have our internal AI lab, where we have capabilities of running different types of models, for instance. Models focusing on text. We can run like the VLM models that are now, that kind of emerge really awesome video capabilities. So, like, what could be next?
Well, for Q9, it's specifically, I guess there's always more to do with the video, right? It's currently fairly limited, but we could outfit him with better cameras or whatever. There's so much stuff to dive in there that he can be equipped with so much more than just what he has now. As far as AI goes, we have our own AI lab, so I guess the first thing we could try is, can we do something with like the depth sensor that he has?
Like the LiDAR sensor.
You can measure distance and you can get a spatial awareness. I guess we could maybe let him walk around on its own. Right now, he's controlled by remote when he moves. Maybe a little bit for safety's sake, but also because I haven't really thought of a good way to let him walk freely and not, get lost.
Well, he scares the living crap out of some of our colleagues.
That's a funny one, on the show floor as well. Like, there's people that are immediately very interested, and there are people who turn around and walk away. So, but what's next? There's the depth thing is funny to play around with. I had like the parking sensor on your car. Like, if you get near him, he would beep or something. That would be like the first. The first, getting the sensor to work use case, and then from there you can, once you have the data, you can just keep on piling stuff and see how far you can take it.
And one thing that I took away from GTC is also that you could build a digital twin based on the robot that you have. So the Unitree G2, like the Go2, has a digital twin version that you can run in Omniverse. And together with the ROS2 operating system, you can basically build whatever you want in a virtual environment and then test it in real life as well, because there's a feature compatibility there.
Yeah, that's one of the things that I looked at from the GTC context. I like of the content, what people are doing with robotics, right? Just for Q9's feature set, and all of them say you need to start simulating, because the real world implementations, that is too slow. You're unable to iterate with a robot that you constantly have to update or whatever. Yeah. Now in our case, it's all containers, right? You can just kill it and restart it quickly. Yeah. But if you want to do more complicated things and you might want to drive motors yourself or whatever, then it becomes potentially dangerous as well. If you mishandle him, or he walks into stuff, or he walks into people and he hurts them, then that might be better in a virtual environment.
Yeah. So I always kind of end the conversation with looking back at the conversation itself and kind of sharing the lessons learned from a mutual perspective. But in this case, I'd like to know what your key takeaways from the project were.
Well, the robotics angle was completely new for me, so that was interesting to look into. It also it clearly highlights, there's so much potential in having a robot connected to like an AI system, whatever that may be, right? We do vision, you do large language, or some other motor control, anything. There's lots of stuff to be figured out. Maybe already figured out by others. I don't know. It's a toy, really. Yeah. But yeah, I guess the sky is the limit at this point. Especially when you can just ask like something like a coding agent, like, hey, can you help me whip up a function that with the 3D data, for example, like point clouds or whatever. Yeah. Can you figure out how I can make a world view of this data? I wouldn't know where to begin if I had to do it myself, other than Google it and then hope that somebody else figured it out. And now the bar has definitely been lowered there for entry. Yeah, that makes it makes stuff so much easier to try out, really, and that's what we've been doing, right, with this. We just started out with, okay, we have a robot and we want to do things to it.
Yeah, and I think that's a great point, because that's also one of my key takeaways. You mentioned that in the first couple of weeks we were working at nights to actually build kind of an alpha version.
Just to prove that it actually can work. Yeah,
and we used a lot of vibe coding to kind of come up with like a first solution. And what we learned along the way is that first solution, and showing a demo that works based on like the sequence or whatever you're gonna run into through the code works, but you also need to take error handling and other kind of conditions into account. And this is where I would argue, knowing how to code, being a senior developer, looking at the code and knowing how to kind of would rebuild it from like a 12-factor point of view really makes sense. So that's one of the key takeaways I had. Like, vibe coding is awesome, and we showed value immediately, but as soon as you want to kind of make that platform a little bit more kind of enterprise capable, you definitely need to look at rewriting the code, or making sure it's fully kind of compliant or aligned to your principles.
Yeah. I guess that's kind of like the thing that interests me most right now in this whole LLM coding assistant development. Right? Will the models be good enough to catch out all the I say mistakes, but they're just design choices, right? And will it smooth over them when it sees them? Right now, it certainly helps if you have lots of experience, that you can give lots of context, right? I want it done in this way because this reason, or I want you to follow this pattern, or I want you to do TDD or whatever. That if you know the language to express what you need, that certainly helps. Yeah. And I can just ask for, hey, build me a function that sends a sit command in this format, and then it will have to figure the rest out on its own. But if I explain, like, okay, now we're using this framework and we're writing in Python, and all of that extra context right at the start, as a simple example, that helps a lot. And then once you start getting into more complex situations, the models that are out there are getting better. But I'm still very much human in the loop right now. Like
Yeah.
I don't approve all the changes, but I do check up on, hey, what have
You
you done?
Yeah, you don't put it in YOLO mode yet.
Not yet.
Yeah,
No.
yeah.
I still check the diffs, not on
Yeah.
everything, but sometimes I'm like, hey, I told you to do TDD. Have you really written the test first, or are you just messing around and having green bubbles where you're just testing something that's completely irrelevant? But those things are slowly being improved. I've noticed. So
Cool. So I'll leave a link to the dog's profile on LinkedIn in the show notes. If people want to follow you on like whatever you're doing
LinkedIn
right now.
really is or harre.dev. You can check out. I write about stuff sometimes.
Yeah.
Not too often, but if I have something to share, it's there. There's a little story about Q9 as well there. I think I still have the video up on the page there. When the first hand gesture worked and he waved back. That was fun.
Yeah.
There was like V1 running locally, all Python scripts on my laptop, blazing fans, all of it running on a single machine. So yeah, if you that's LinkedIn, just type in my name or the link, I guess.
Yeah, I'll leave the link to the show notes.
Yeah.
Also, like I think one of the things I'm working on is to kind of open source some of the things that we built so far.
Yeah.
So definitely we'll keep you updated on that as well.
It's still in the very experimental stage. It's all working and it's all very well safeguarded, but there's very little testing and very little quality assurance on there.
Yeah.
So we might want to improve that before we send it out into the public. But we do want to make some of this stuff open. Yeah.
Awesome, man. Well, Sander, thanks so much for being a guest on the lab.
Thank you for having me.
So thank you for tuning into the Private AI Lab. Don't forget to subscribe on Spotify, Apple Podcasts, or YouTube, or the Private AI newsletter on LinkedIn, and visit Johan.ml for more insights and experience. Experiment complete. Until the next one, stay curious.
Private AI Lab.